Welcome everyone to the webinar about unlocking the power of synthetic data generation and methods, use cases, and customer stories. Today we are going to deep dive together with you into best practices, and we are also inviting you to collaborate. So in case you have any questions, feel free to drop them in the chat. My name is Wim Kees Janssen, one of the founders of Syntho, and I have a background in the financial sector. There I was developing the tech solutions, and in that role typically work with the most privacy sensitive data, always strapped into all kind of procedures in terms of getting access to the data. And that was my motivation to really build smart solutions to make sure that we have the data needed to build those solutions. With me together also Uliana.
Hello everyone, my name is Uliana. And I'm business development executive at Syntho, mainly working with the customers to help them to understand the power of synthetic data and the use cases within their organization. So my background is regarding the AI software development last 7 years, and I will be really happy to have this conversation today with you. So I think we will start with a couple of interesting things today. So we will touch upon what is synthetic data about, and then tell about the real data limitations and how we can overcome these problems with synthetic data, about the regulation landscape, because it's really important, especially in the area of data sharing, then about the data evolution and market size, about synthetic data generation methods, and how we can use it and where we can use it, and then the use cases and case studies. So they will touch upon a little bit of product overview and small demo that you will give a chance to understand how it looks like and how easy it's to use. And then we can finish with Q&A, but also please welcome to ask a Q&A during the session. We'll have an opportunity to pick some questions. Yeah, so what I would like to share with you is a couple of polls we ran before in LinkedIn to share a little bit. So we asked the audience in different groups, but also our own network, that if they're using already synthetic data. So it's around the 63% that no, they don't. Also, we asked that how long and how many manual work you need to do to have a good test data. So mostly everyone, 88%, told that, yeah, it's really time consuming. And the last one was about how test data actually reflect on a production data. So here I feel still we have some area for improvements. So it's good to ask the audience, but on LinkedIn, but also it's interesting to ask you. So that is why I would like to launch this poll question. So are you using synthetic data within your organization? So first it's no if you don't. Second one, that you are actively exploring the market and vendors. And third one, that you are already adopting some synthetic data platforms. And the last one, that is actually the part of your daily routine. So please vote. And yeah, I think we can give you a couple of seconds to voting and a little bit to understand how it's organized in your organization. But let's assume. So I think at least we will have some main votes in the B and C, because it usually works like this. So yeah, administrator will help me to do it. Oh, nice. I have already the results, but I also see you also. So first, now planning to do the market research. Super. So it will be really helpful webinar for you. And we have actively exploring it yeah, as well. And we already have someone that's actively yeah, partaking it into the daily routine. So that's great. So let's maybe start. So I would like to tell a little bit about synthetic data opportunities itself. So about Syntho. So we are a startup based in Amsterdam, and we established 3 years ago. And I would say what is really nice, because now 3 years later, we have a ready enterprise level platform ready to use. And we have more than 20 people in our team, mainly working to create the best synthetic data generation platform. So what I can share so far is that we have quite a real data limitation. So the real data is not accessible. So either it doesn't exist, but you need it for test and development purposes. You may have inefficient data or imbalanced data. So with all these things, actually synthetic data may help you with. So what actually opportunities do you have? So first, it may help you to increase the industrial collaboration. It may help your organization to have more profit, because you will unlock the data and you will have access to these insights. And the last one, that it's privacy by design. So it will really help you to move faster with your data. So regulations, how without them? I think what is nice in the regulations around the synthetic data, that it's actually the same as for anonymized data. So we have statements from EU regulations also related to the HIPAA compliance, that synthetic data is the same as anonymized, and you can use it in the same way. If speak about Gartner and market size, what we see so far, that in 7 years, mostly synthetic data will be used for AI tools. So less and less companies will use the real data. And also, if you will have a look on a hype cycle of artificial intelligence, so we see that now generative AI in a hype, but not synthetic data anymore. So we pass this hype in terms of new technology, and now more and more companies actually adopting the platforms. So the good statements, I would say, is good for us, that around synthetic data will really help to reduce the cost for data acquisition up to the 40%. And also that in 1 year, it's or next one, to be honest, around 60% of data will be synthetic. So it's a big promises, big expectations. So we will see how it goes. I think the last slide in this section, it's about the evolution. So maybe to give you a little bit the idea how this development of synthetic data went step by step. So first, before, usually companies use the real data as a production data. And they also use now still the AI modeling for like a real data in AI modeling. But what we now see so far, that it's less related to a real data because of restrictions, but also about the risks. So now we see it's mainly used like anonymized data, mock data, rule-based data, or real data still for AI modeling. But it will really change soon. So even in the future, we will have more AI generation synthetic data for AI. And then we will have AI-driven mock test data. So you will need to do less and less manual, and more it will be automated. So a little bit also the introduction about the data generation methods will be done by Wim Kees.
Thanks. And yeah, looking forward to deep dive into the generation methods, because synthetic data is a topic, but there are actually various types of synthetic data. So let's discover what the options are. First of all, I think one of the options is what we refer to as AI-generated synthetic data. The second option is synthetic mock data. And the third option is rule-based synthetic data. So let's deep dive further into what we actually mean with those concepts. First of all, AI-generated synthetic data. This is a method where data is generated by artificial intelligence. With artificial intelligence, we aim to reproduce all the patterns and relationships that are in the real data. to generate a synthetic data set with all the patterns, the statistical patterns mimicked in such a way that the synthetic data can even be used for analytical purposes. And that's why we refer to this result also as a synthetic data twin, because the idea is that the synthetic data is statistical, really similar in comparison to the real data. The second topic is what we refer to as mock data. Data, dummy data that is randomly generated from a mock generator. A typical example could, for example, be mock names, mock addresses, mock social security numbers, and of course, many more. And the third approach is rule-based generated synthetic data. That is basically predefined business rules that you want to take forward in generating the synthetic data. Make sure that the synthetic data really reflect the business logic that you want to reproduce. So those three options are available and actually supported by the Syntho engine, and we will come back to them with the demo in the end. The next question is which industries typically use synthetic data? How we really see that organizations that typically work with, on the one hand, sensitive data, and on the other hand, typically have an ambition, need, or urgency to actually innovate with that data. Typical organizations where that is the case is healthcare, the financial services, public organizations, retail, education, and manufacturing. Those industries really benefit from synthetic data because it allows them to unlock that sensitive data in order to realize those solutions that they want to build with synthetic data. And then I would like to ask the second question to you. Where does your organization stand in the adoption process of synthetic data generation? Are you exploring synthetic data? Have you decided to use synthetic data, and are you actively exploring the solutions? Do you use synthetic data in some projects? Maybe not within the whole company yet. Or are you using synthetic data really on a full company level? Let's take 20 seconds to fill in this poll, and really curious to also see the results. Let's take a look at, I see a lot of people in this call are actually exploring synthetic data. Some decided to use synthetic data and are actively exploring the offering. Some use synthetic data, but not yet within the full organization. And I see only one person that is actually adopting synthetic data really within the full organization. And yeah, that's of course something that you could do, really bring synthetic data to production. But of course, we have this webinar to really make sure that you have all the knowledge there relevant for the exploration phase of synthetic data. That brings us to the next topic of today's webinar. What are actually synthetic data use cases? Why are we actually using synthetic data? The typical use cases that we see are analytics, test data, and data sharing. So let's deep dive together in each of those use cases and what best practices are in terms of using synthetic data to realize those use cases in a good way. To do so, let's start with use case 1, analytics. And for analytics, we typically use AI-generated synthetic data. Typically, organizations have an original data set. That's what we see there. That data set can be privacy sensitive, therefore you cannot simply use it. And therefore, we can use our Syntho engine and use AI-generated synthetic data to really generate a synthetic data twin that mimics the patterns of the real data. As alternative to using the original data, then your data scientists, developers, data analysts can then use the synthetic data to develop the models. And the real benefit of that is that, on the one hand, as we are working with synthetic data, they can have much faster access to the data. often they can have much more data, which is of course a strong foundation for your data science team to build those models. Then in the development phase, when you really work towards your final model, when you have your final model, you have your model, you know exactly which data you need, what the feature important is, then optionally you can score the model on the real data. And the benefit of that is that you have an end-to-end process where you can work on synthetic data in a much faster and agile way, while still being able to validate or score your models on real original data without actually having your data scientists needing to see the real data. And with analytics, I think it's good to mention that we are talking about anything ranging from business analytic, dashboarding, BI solutions, towards actually model development, artificial intelligence, machine learning, etc. So what's the idea? You have the original data. We use AI-generated synthetic data to generate a synthetic data twin that really mimics the patterns of the real data. Potentially, as we use generative AI, we can also use upsampling, which means typically we use generate the same amount of records that are in the original data set, but we can also generate an unlimited amount of data, and we'll come back to that as well today. So summarizing, typically you have the original data set, the Syntho engine, we use AI-generated synthetic data to generate a synthetic data twin. The key question always is, how accurate is the generated synthetic data? With Syntho, we basically take two approaches to validate this. First, we always provide a quality assurance report where we compare the original data with the synthetic data, and we will show that in a bit. Second, we work with external experts that do frequent validations of our synthetic data, in this case SAS, to make sure that we have also this approved with an external objective organization. So let's deep dive into some of those results. First, our quality assurance report. Here we compare the original data in gray with the synthetic data in green. And we see here the distributions at a frequency of variables that are in a data set. And we see, for example, at the age, and we see that there are quite a lot of persons with an age of 30 years old and only a few persons with an age of 80 years old in this data set. And we see that that is well reproduced in the generated synthetic data. Also, the male-female ratio is well preserved. And that's, of course, the goal of synthetic data generation. We want to mimic the original data as closely as possible. Next to the distributions, we also preserve correlations and the relationships between variables. Also, they are preserved, and typically you can illustrate correlations in a correlation matrix. To make it visually more appealing, we use color intensity to illustrate a stronger correlation with a stronger color. And we see here that the correlation matrices are well preserved. Finally, we have also more deeper patterns, a combination of variables, also bivariate distributions, bivariate correlations. Also, they are well preserved. If we look at the left top, we see, for example, the distributions of the healthcare expenses and the birthday year. And we see a clear pattern that the older a person gets, the higher the healthcare expenses will be. And we see that that is also well preserved in the synthetic data. Those who are interested can request a sample quality assurance report from us by sending an email. Next to this, we have the external assessment with, in this case, SAS, to make sure that we have our synthetic data also approved by them. So let's take a look at some of those results. Here we use really predictive modeling on synthetic data. What do we see in this slide? We see 4 models, a neural network, logistic regression, a gradient boosting, and a random forest. We use the area under the curve, AUC, as measure for the model performance. And an area under the curve is always between 0.5 and 1. 0.5 basically means that the model predicts randomly. You can better toss a coin. And 1 means that the model is always predicting correctly. So the area under the curve is always somewhere in between. And the goal was really here to validate that if we train models on original data and the same models on synthetic data, how will the predictive power be the same? We use anonymized data as benchmark because that's typically one of the alternatives. And typically, with anonymization, you have to remove PII and do more obfuscation, aggregation, and anonymization to make it more difficult to identify individuals. In a process, you have to destroy the data. And the paradox here is that the more you destroy the data, and the more you make it difficult to identify individuals, but the more you destroy your data, making it less suitable for analytics. And that's also what we see here. So first, we can really see that the synthetic data scores and is as good as real in comparison to the original data. Anonymized data shows worse performance. I have to say here that we anonymized quite heavily because here the benchmark was really that individuals should not be able to trace back. So we had to aggregate quite a lot. But in general, the more you anonymize, the more your area under the curve will lose accuracy. In a solution that works easy, fast, and scalable, because the methods used here can be applied on any structured data set. So it doesn't matter if we are working with healthcare data, finance data, telecom data, etc. Data sharing, the second use case. Typically, organizations work with data, but they cannot simply use and share that data. And that counts for internal data sharing, but also external data set sharing. A lot of organizations face data silos. It takes a lot of time, effort, and bureaucracy to get access to the data. But sometimes you also need to share data with an external company. That can be a stakeholder, a partner, but also a startup or a vendor that you want to do a pilot with. And you want to make that as easy as possible. As alternative to sharing real data, it's an option to share synthetic data, really accelerating the process and cutting costs relating to the expensive bureaucracy and paperwork. Let's take a look at a case study. Here we worked with a leading hospital that is intended to do research on cancer data. And this data is, of course, the most privacy-sensitive data. Consequently, this hospital cannot simply use and share that data. It takes a lot of paperwork, effort, time is lost. And this is challenging because, especially in healthcare, there's a high pressure to innovate. There are not enough resources, and we need to be smarter with the resources that we have. In this case, we synthesize this data to make it more easier available to do this, in this case, cancer research. So we started here with also a validation comparing the real data with the synthetic data. In this case, this was also executed by SAS by using SAS Via, one of the leading platforms for analytics. And here we see the correlations being preserved for this healthcare data set. Also, the area under the curve, the measure for model performance, was well preserved, both for the training and validation set. And finally, also the variable importance is well preserved. And the variable importance is an indicator of which variables have a high predictive power for the models. This was the starting point to really start with this research and to predict deterioration as part of this cancer research. Here we see some of the results that we were able to demonstrate. In this case, the target was predicting, in this case, data deterioration as part of this cancer research. And we were able to predict this with an area under the curve of 0.74, really demonstrating that we are able to build models, predictive models, on real-world data in a real-world use case. And the conclusion from this use case is really that we can unlock privacy-sensitive healthcare data with synthetic data within the hospital to realize data-driven insights. In this case, with less risk, more data, and faster data access. And this was actually the starting point of this research, because the next step was not using only this cancer patient data set from one hospital, but using 2 cancer patients data sets, in this case from 2 hospitals. How did we do this? We synthesized the data sets, creating a synthetic data set, because the hypothesis is that the more data we have and the richer data we have, the better impact that could have on the predictive power of those models. And typically, if you work with hospitals, hospital A could have a really different population of patients in comparison to a hospital B. So there's really value of making sure that you can do analytics on those joint data sets. What is the result? And we were here able to realize an area under the curve of 0.78, really demonstrating that more data can indeed have a positive impact on the performance of those models. And this really highlights also the value of having a strong infrastructure and being able to use and share data in a privacy preservative way. Because if we are able to do so, we can really realize business and social impact. If we summarize those results, we can really conclude that we can use synthetic data even for clinical research, for research purposes, demonstrating that synthetic data is indeed as good as real in comparison to the original data. Second, we illustrated that access to more data can have a positive impact on the models. And finally, I think one of the features that I mentioned in the beginning is what we refer to as upsampling. How does this work? For example, if we have a data set with a certain imbalance, in this case, we see a data set with only 1% of fraudulent people, luckily. But if we want to build, for example, predictive models in predicting fraud, you want to have more of those cases of underrepresented groups. So what could we do with synthetic data generation? Because we use generative AI, we can upsample, and in this case, balance the data to 50% fraudulent people and 50% normal people. Anyone that is interested in this use case can also share an email with us, because we have a report that we can share as well on a real use case about fraud detection with upsampled simple data by using AI-generated synthetic data. Then the third use case is what we refer to test data. And our ambition is to generate smart synthetic test data to make sure that you have proper test data to build your tech solutions. What are the typical test data challenges that we aim to solve with Syntho? First, typical test data solutions realize a way that the test data doesn't really look like real data. Therefore, that data is typically not valid and cannot really be used to do testing. Without valid test data, you cannot do valid testing, and that will potentially be resulting to bugs in production. Often solutions do not preserve referential integrity over datasets, databases, and even systems. And I think this is one of the unique functionalities that we have developed with Syntho to preserve this referential integrity even across systems. Often, test data generation takes a lot of time. It is challenging to generate large data volumes, and that is, of course, needed to do load testing or stress testing. Often, test data is not up to date, and it's not easy to maintain. While this is needed, because your test data always needs to reflect your production data as closely as possible. And that will result in really boundaries in the test data. And that is, of course, what you want to solve, because if you want to develop proper tech solutions, you need to have proper test data. And what we see is that a lot of organizations suffer from what we call legacy by design, because they simply have a really outdated test infrastructure with outdated test data. And that is really mismatching if you want to generate or build the future with your tech solutions. So what can we do to solve this? First of all, I think it's good to understand the difference between what we refer to as PII and non-PII. PII stands for personal identifiable information. This is any information that can be used to directly distinguish or trace back individuals. And only one person has the same threat. And an example could be, for example, first names, last names, phone numbers, social security numbers, bank numbers, etc. Second, non-PII and non-personal identifiable information. And this is any information that on its own doesn't directly distinguish or trace back individuals. And more than one person could have the same threats. However, when combining non-PII, you could potentially identify specific persons. So it's not the case that non-PII is non-sensitive. And examples of this is gender, age, income, profession, insurance coverage, etc. What is the toolbox that Syntho offers to realize and generate smart test data? First, we facilitate synthetic mock data. We are able to generate rule-based synthetic data. We have an AI-powered PII scanner to de-identify in a smart way. And we support masking functionalities. We can use subsetting, and we can use upsampling to create a larger or a smaller version of your database. Let's quickly go through each of those solutions. So synthetic mock data, as mentioned, we really generate data based on a predefined set. So those can be mock first names, mock last names, mock social security numbers. Rule-based synthetic data, you really define your business rules, and we generate synthetic data accordingly. The PII scanner, our AI-powered models can identify PII automatically in your database and replace them by a mocker, a pseudonym, or an encryption code. And masking can be applied on non-PII to make sure that also non-PII is masked. Subsetting is a functionality because a lot of organizations have a massive production environment with a lot of data. And you do not want to have a massive test environment because that's really costly in terms of computing cost and hosting environments. So with subsetting, we can shrink a database to make a smaller subset in a way that preserves the referential integrity across tables, databases, and systems. With upsampling, we are able to generate more data. Sometimes you do not have a lot of data. You have not enough data, so we can use generative AI to upsample the data towards the need that you have. Those combined are best practices to really provide you with an up-to-date test environment with proper test data. Let's go through some of the use cases where we facilitate organizations with proper test data. Syntho is working for a leading Dutch bank, online bank, for the development of its tech solutions. And that can, for example, be CRM systems, client systems, payment systems, investment systems, etc. To develop and maintain them, you of course need to have a proper test environment with proper test data. Also, on top of those systems, this organization is building the tech solution, for example, the mobile banking apps, client portals, online environments, and many more innovative solutions to stay competitive. However, the test data at this organization was outdated. Typically, developers were responsible for generating the test data. They used a lot of open source methods with a lot of limitations, typically related to the data size. That results a lot of legacy within the development process. Hence, we supported this organization with our toolbox to really make sure that they have a proper and state-of-the-art test environment with test data that really reflects production data. And the benefits for this organization are release faster and shorten the time to market, reduce bugs in the pre-production test and reduce bugs in production, save costs related to the test data maintenance, and make sure that developers and testers can spend time on their actual work instead of maintaining test data, enhance data privacy and security, and flexibility and scalability, because with the platform, the test environment can be up to date in an easy and fast way. That brings us to question 3. For which purpose do you intend to use synthetic data? Are you intending to use synthetic data as test data? Are you intending to explore synthetic data for analytics? Are you intending to explore synthetic data for data sharing? Or maybe all of them? Curious to see the results. Interesting to see the results. So I see quite a lot of people in the call are exploring synthetic data for analytics. So I think that is that's interesting to see. Also, a couple of people are exploring synthetic data for test data, and some are exploring synthetic data for all of these use cases. Yeah, and I think that could be a starting point to really show our platform and to deep dive a little bit in how you can actually generate this synthetic data in a proper and scalable way to make sure that you can really use and generate synthetic data in production on an enterprise scale.
So now I will do a quick product overview. So to give you idea how we organize the product and our Syntho engine. So I think what is really important is to know that first one, it's privacy by design. So we deploy the solution in your secure cloud or on-premise infrastructure. And we as a Syntho, we are not data processors and we have no access to the data. That is why it's secured. Second one, it's a data quality, because we work a lot in terms of make sure the data is high quality, it's perform like the engine it performs stable, because especially for AI generation, it's a key point. And the third one, that it's easy to use. If you try the open source packages, I think you will not see the data quality, but also the usage. It's quite hard because you need to have some certain knowledge about that, about the program. So we automated as much processes as possible from our side. And I think what is really important to differentiate. So as the first one, it's easy to use. So you can generate synthetic data in simple 3 steps. Second one, it's fast. So our clients sometimes synthesize the data in 15 minutes and right away are able to share the data. Third one, we work with the massive data sets, and we have supporting access and to connection to the leading databases. So you can easily install the solution and do plug and play. Next one is time series. So especially in a hospital and in a healthcare organization, we are actively work with. They have a lot of time series data and they need to do the longitudinal data analysis. And the last one, that we have already AI-powered PII scanner and mockers. We have also the connectors and workplace. Workplace is actually the really powerful tool that you are working with your mates at work and you can do synthesization in parallel. So now I would like to move to the demo, because I think a lot of us, of you really interested how we can organize it in a proper way.
Thanks, and yeah, let's proceed with the demo. I think before we deep dive with the demo, I also would like to highlight that we have the opportunity to ask questions. You can do that via the chat. If you provide us with your questions, and we received already a couple of them, we will cover them also during this presentation. So if you have questions, please put them in the chat so that we can cover them during this webinar. I think I need to share my screen, and to do so, I need to select the right screen. So let me do so. I think how we typically deploy, as Uliana already mentioned, is that we deploy in a safe and trusted environment of our customers, typically via Docker and Kubernetes. As you can see here, this is the high over deployment architecture. And with Syntho, we provide our customers with an easy-to-use web user interface to generate synthetic data. On top of that, we also, some of our customers are using our REST API, for example, to integrate our engine in a pipeline. Let's navigate to our platform. So with Syntho, we want to make synthetic data generation as easy as possible. So users can log in via the user interface. And with Syntho, we typically work with workspaces. And a workspace is basically an environment to set up your synthetic data generation job. How do we start? Typically, we connect with the source database. So that's basically the database where the original data is stored. And we connect to the destination database. That's basically the destination where you want to write your synthetic data to. To connect to the data, we support various out-of-the-box connectors. This is our demo environment, and here we see the most frequently used connectors. But next to that, we have also more connectors that we can deploy as part of your solution. Once we have built this connection, we can open the workspace. Today, I'm going to open a pre-generated database. In this case, a COVID patient sample dataset. This is basically the environment from which you can configure and generate synthetic data. What do we see here? On the left side, we basically see all the tables that are in the database. One can potentially recognize that this is a typical healthcare database, for example, with a data set, in this case, the table containing patient data. Here, we can easily drag tables from synthesize. If we position a table in the synthesize, it basically means that we synthesize the table with our AI algorithms, so AI-generated synthetic data. We can also navigate tables to duplicate, which means that we will copy-paste the table as is. Or we can navigate tables to exclude, basically meaning that we will not take this table into account as part of this synthetic data generation job. Here, we open, for example, the patient tables. And what we can see here is the real data. In our user management, we can easily configure users that they can either see the real data, that they cannot see data, only the column headers, or only the first 5 random variables. For this demo, we want to show the real data to make it also to get you a better look and feel about how it works. Basically, what we can do if we want to synthesize this table, we can easily press generate, and then this table will be fully generated with our synthetic data, together with all the tables that are listed here in the synthesize, or duplicated for the tables that are listed in the duplicate. One important functionality that I would like to highlight is that we automatically read the data from the database. We automatically recognize which data types we have in the table, and that is automatically categorized. What you might recognize is that we have an indication for PII for all the PII columns. I think it's good to note that this is something that I didn't do manually. How does this work? In the top tab PII, we have our PII scanner. We basically support 2 scanners, a shallow scan and a deep scan. The shallow scan scans on the metadata, and the deep scan scans not only on the metadata, but also on the data itself. After scanning the database on PII, it will automatically identify the PII columns, the columns that contain PII. In this case, for example, the patient address, patient driver ID, first name, last name, etc. From there, our platform automatically suggests a mocker, and a mocker is basically a predefined set of dummy variables. Here we see, for example, the first name and the last name. I already confirmed them, but you can automatically easily confirm them in the platform. And from there, you can potentially edit them. For now, I'm going to quickly show how it works. Here we generate, for example, first names from the United States. And as you can see, it will automatically provide you with some preview examples. This is supported in any locale, so we can generate, for example, Dutch names, and we can also generate any other names that you want to generate. Next to the first name mocker, we have many more mockers in place that you can use. An example could be a custom text mocker. And here you can, for example, configure a certain pseudonym or encryption code that you want to use. Here, I'm gonna use digit to replace it with a number and a question mark to replace it by any variable from this list. As you can see, it will automatically generate accordingly. This can be changed to make sure that it will reflect the variables in that table. Here we have the consistent mapping functionality to make sure that we consistently map the same name with the same mocker. And this is a way that we support across tables, across database, and across systems to make sure that you can preserve referential integrity over datasets, over databases, and over systems. Syntho supports over 180 mockers to be able to generate data easily and fast. Here I will confirm, and thereby it will be automatically saved. What will happen now, because I indicated mockers, is that we will generate this synthetic data with AI-generated synthetic data, and we will preserve the identifiers. In this case, mock identifiers. And this is a way to have an AI-generated synthetic data set with mockers in place. We also have the identifiers in place. One way in which we optimize our AI-generated synthetic data capabilities is time series data. We work with leading hospitals and life science organizations that work with the most complex time series. A lot of time series strings, a lot of complexities in a time series because they can be unequal spaced with unequal length. And we want to make sure that that is reflected well in the synthetic data and that the correlations between the time series and the, for example, patient table is preserved. That is one of the ways how we supported the platform. Next to this, we support various rule-based generated synthetic data methods that we support in the platform. We can also support them with the mockers. And for example, here we have a way to do a distribution, and then it basically is a way to generate synthetic data from a certain range. During this webinar, we are not going to deep dive too much into the mockers, the rule-based synthetic data generation, and the test data capabilities. Those will be treated more in depth during the next webinar. What I want to show here is the numbers of rows to generate. This can be used to upsample. So what we see here is that the original data contains 1.2 million rows. Here we can simply add numbers to make sure that we can generate more data. And that's a way to easily upsample the data. From here, as we are talking for a part about AI-generated synthetic data, one of the questions is always how accurate is the synthetic data? And as mentioned in the beginning, for that we create a data quality report where we compare the original data with the synthetic data. That is something that I would like to share as well. What I'm going to share now is the quality report that belongs to this table. What do we see here? We see here the univariate distributions. Again, here in gray the original data and in green the synthetic data. And we see here that the variables are well preserved. We also do this for the correlations. This is a little bit bigger correlation matrix as this is a bigger data set. But as you can see here, also the correlation matrix is well preserved. Finally, we have the bivariates, and as there will be a lot of combinations, we support also them, and as you can see here, these are also well preserved in the synthetic data. This is to give you an idea about the quality assurance report, where we compare the original data with the synthetic data. This provides you with a high-over demo of our platform. Of course, we have many more functionalities, specifically for the use cases around test data. We will host a webinar in the new year, specifically about test data generation. And we will also in the new year host webinars about industry-specific webinars related to time series data. For example, in healthcare, where we will deep dive further with some of our customers and show best practices for real-life use cases. Now, I would like to hand over the word back to Uliana to also provide you with an idea how it would look like if you would like to start exploring synthetic data with us.
Yes, I see. Yeah. So I think we are asked by clients in a lot of times that it's great that you have a self-service platform, but synthetic data is something new for us. So we are not sure we can really easily capture how to work with this and how easy it's to. So that is why I would like also to share a little bit about the support we as a Syntho provide to our customers. So I think you see now it's a kind of example of a platform project timelines. So when we start any project together with our customer, we started from kickoff when we figure out the requirements, we do the planning for the project, and then to plan how we are deploying and then what we do next. In the next phase, usually we do deployment. It can take from 1 week till 1 month. It depends really of how fast your technical team can move and set up needed infrastructure. I think in terms of infrastructure, it's really interesting to share that we are not using the GPUs for data synthesization, only CPUs. And after the deployment, everything works and it's live, we do the Syntho bootcamp. It's actually the process when we educate our customer how to use the platform, what is the best approaches, depends on the data set you would like to synthesize or data type. So we really try to make sure you know how to do it and do it in the best way. And we really encourage you to use as much platform as possible to get the maximum result. And after that, we help you to generate couple of data set to help to run the QA report, really to understand how it works. And then usually customers work themselves. But also we have an opportunity for the support options. When you have a live chat with us, you may ask some Q&As along the way of data synthesization. And then you are more sure that you would like, you know how to use it, and you are not alone with the Syntho engine. So we are all the time together with you to help you to make sure you know, how to use it in the best way. Yeah, I think we are quite sharp on time. Thank you in Q&A. We are really open to discuss further. So just let us know via website, or you can schedule the demo or intro also via website. We will also share this recording with everyone who participated. So feel free to share it with your colleagues if you see it can something be valuable for them as well. Do you have any questions?
Yeah, and I think in that email we shared a recording. We will also share the slides. If you are interested in specific materials, for example, the quality assurance report, the user documentation, the special offer, or any other relevant materials or questions, feel free to reach out. We are more than happy to share them with you. Next to that, we are also going to host more webinars in the future. So this was more like a general webinar where we covered as much topics as possible to all of the use cases and all of the functionalities. In the future, we will host more webinars on specific topics, for example, specific use case, specific functionalities, or specific industries. We will keep you updated with that. And then, thanks all for attending. Hope you are able to inspire you, and wish you all a good day or evening, depending on where you're dialing in from. Thank you very much.
Thank you.